I'm now moving on to the homework questions from lesson number 2 in the circle geometry chapter. So for problem number 1, I need to find the missing angles. So for this particular problem, for the very first question here, I'm using the concept of angles on a line, and angles on a line add up to 180 degrees. So mathematically, you can just do 180 minus 125, and that gives you a value of 55. So this has angle 1 has a value of 55 degrees, and you can see that those two angles added together will give you a sum of 180 degrees. For letter B, these lines right here, this green line here and this green line arrow there, that just means that the two lines here are parallel, and that's going to be important later on in this problem. But the very first thing I want to do is, I know this part right here is a radius, so I'll mark in my radius like that. And I also know that this line right here also represents a radius, so I'll mark that in. So I have an isosceles triangle there, so what that means is the two corner angles have to be equal. All right, so that's step 1 of this particular problem, because angles in a triangle add up to 180 degrees. And because it's parallel, the general rule is, let me see if I can just draw this here correctly here, and let me just erase this here. The general rule is if it's parallel, we can use one of the alternate interior angle properties. So there's my Z shape there. So when you're using the alternate interior angles property, basically it means that these angles here in red that I'm drawing, the Z shape there, those two angles are equal. So if this angle here was 40 degrees, that means angle 1 also has to be 40 degrees, because the two lines are parallel, so that way you can use the alternate interior angles property. So angle 1 is going to be 40 degrees. Okay, let's move on to letter C here. And for letter C, I can use the isosceles triangle property, because this is a radius, and over here this is a radius. So this angle here has to be 65 degrees. And I know in a triangle, angles add up to 180 degrees. So I can do 180 minus 65 minus 65, and that gives me 50 degrees. So it's going to be 50 degrees for that particular problem. Okay, let's move on to letter D now. Okay, so for letter D, here's a radius right here, and here is another radius right there. So if this is 30 degrees, then this has to be 30 degrees. And then if you look into this triangle here, we know triangles add up to 180 degrees. So if I have 180 degrees minus the two 30 angles, I know this has to be 120 degrees. And then I know that the blue angles, these two blue angles, they're equal because they're vertically opposite. So if the bottom angle is 120, that means the top angle right above it also has to be 120 degrees. The angles are going to be the same. All right, so that angle there is going to be 120 degrees. Okay, let's move on to a letter E here. Now for letter E, one thing that you need to recognize is that the sides here, for the bigger triangle, all sides are equal. So if all sides are equal, then you're actually dealing with an equilateral triangle. And for an equilateral triangle, that means all the angles are equal. So each angle has a value of 60 degrees. So, sorry, my pen's not working here. So 60 degrees on the top, bottom, and the sides. All right, so let's go ahead and put a 60 degrees at the top here. And why that's useful is because if I take a look at this upper angle here, this is called an inscribed angle. So I'll use the letters IS, inscribed angle. And if I look at that inscribed angle, where does it open up to? Well, follow the two sides here, and it opens to this arc right here. That's key. So that inscribed angle opens to that arc. This is one of the kind of key properties for circle geometry, because ask yourself, what other angle opens to that arc? Well, another angle that opens to that arc is this red angle right here. This is called the central angle because it's the angle in the middle. And if you follow the sides, it also opens to this exact same arc, which I'm highlighting in blue there. So the rule is, if the inscribed angle and the central angle open to the same arc, What that means is the central angle, which is in red here, it's going to be double the inscribed angle. So if the inscribed angle is 60, if I double that, this is going to be 120. So angle 1 is going to be 120 degrees because the central angle is double the inscribed angle if they open to the same arc. So that's one of the main rules for lesson number 2. Okay, let's move on to letter F now. And for letter F, I have a radius right here in green, and I have another radius right here in blue. So there's my isosceles triangle. And now I can use angles on the line here, because if this is 70 degrees, then the angle that's attached to it, this whole angle right here, which I'm highlighting, trying to highlight here in black here, that whole angle here is going to be add up to 180 degrees. So 180 minus 70 is going to be 110. All right, so what that means is this angle right here is going to be 110 degrees. And now I have my isosceles triangle set up, so that means that these two corner angles have to be the same, and they're both going to be 35 degrees each, because that would give you an angle of, that would give you a triangle that adds up to 180 degrees. So angle number 1 is going to be 35 degrees by using the isosceles triangle property. Okay, let's move on to letter G. And for letter G, right now there's a 90-degree box there, so it's perpendicular, so that's 90 degrees. And basically all these blue angles I'm highlighting, since they're at a center of a circle, that adds up to 360 degrees. So the math now is going to be 360 degrees minus all the individual angles, so minus the 90, minus the 70, and minus the 80. And that should give you the leftover value for angle number 1. So if I go to my calculator here, that gives you a value of 120 degrees. So this value has to be 120 degrees, and then that would add up to 360 degrees to complete this, the full-on circle there. Okay, let's move on to letter H. And for letter H, what we're going to do is we're going to continue to draw in radiuses. So here's one radius, there's another radius, there's another radius. And if I take a look at all these green angles are going to be equal, because they're all triangles. All the triangles are the same there. So if I look at the center there, 360 degrees is going to be divided equally by 5. So I have 360 degrees divided by divide that by 5. And if I do that, that's going to give me 72 degrees. So each of these angles will be 72 degrees, and that means angle number 1 has to be 72 degrees. Okay, let's move on to the next page here. Question number 2. Mark angles congruent to angle number 1. Okay, well, congruent basically means angles that have the same value as angle number 1. So here's angle number 1. Now angle number 1, this is an inscribed angle. It's an angle that touches the edge of the circle. And if you follow its sides, anytime you have an inscribed angle, you should always follow, anytime you have an inscribed angle, you should follow its sides and ask yourself, what arc does it open up to? And the general rule is any other inscribed angles that open to that same arc are going to be equal in value. So this angle over here, which I'm highlighting in blue, if I follow the sides, it also opens to that same blue arc. And if I mark this side over here, this is another inscribed angle because it's an angle that opens on the edge of the circle. If I follow its sides, it literally opens to that same blue arc. So what that means is these angles I'm highlighting in red now, the check marks, all these angles are going to be equal in value. So for example, if this angle was 30 degrees, just change my color here, that's 30 degrees, and that means this is 30, this is 30, and that's going to be 30 as well. So that's how that property works. Okay, let's move on to question or letter B here. And over here I have this green angle has the value of 2x plus 15, and that's an inscribed angle. Now once again, follow the sides of the inscribed angle and it opens to this arc, which is this guy right here. And then check out this inscribed angle over here, which I'm highlighting in red. So very close to the green angle. So if I follow its sides, and if I open them up to this arc right here. Sorry, the pen's not working. That's an arc as well. And you'll notice that these two arcs are same. So the two inscribed angles open up to the same arcs. So what that means is those two inscribed angles are equal. So what that means is the 2x plus 15, which is this guy right there, is going to be equal to the 3x plus 2 because both of them are inscribed angles and they both open to arcs. The arcs are different visually, but because of these signs here that I'm highlighting in black there, that means the two arcs are the same. So that means the two inscribed angles are opening up to the same arc. So that means the two inscribed angles have to be equal. So now I have this algebraic expression right here, and all you have to do here mathematically is I'm going to take this the 2x here and the positive 2, and I'm going to interchange those two pieces. And if I interchange those two pieces, I would get 3x over here minus 2x, and then the 15 would remain. But if I bring the positive 2 to the other side, it becomes negative 2. So this would become 13 equals to, well, 3x minus 2x is going to be 1x. So x equals to 13 for that particular problem. Okay, let's move on to another angle question, letter C. Okay, so for letter C, I have an inscribed angle right here in green. And if I follow the inscribed angle, it opens to this arc right here. And if I go over here, this blue inscribed angle, if I follow its sides, it also opens to the same arc. So this has a value of 35 degrees. And now you have a triangle over here, and triangles add up to 180 degrees. So 180 minus the 100 minus the 35. And if I just go to my calculator to do that really quickly, I get a value of 45 degrees. So that's the value of angle 1. Okay, let's move on to letter D. And for letter D, there's 40 degrees here and there's 110 degrees there. So I can find this red angle in the corner there because angles in a triangle add to 180 degrees. So 180 minus 40 minus 110. And if I go ahead and compute that, I would get 30 degrees. So this corner angle here is going to be 30 degrees. Now this is an inscribed angle here, and if it's inscribed angle because it opens to the edge of that circle there. And if I follow its sides there, it opens to this arc, right? That blue arc. And if I look over here at angle number 1, which is another inscribed angle, if I follow its sides, it also opens to that same arc. So since the inscribed angles open to the same arc, that means the inscribed angles are equal in value. So angle number 1 also has to be 30 degrees. Okay, let's move on to letter E. All right, so for letter E, I think the same themes start repeating. So we have an inscribed angle right here, and it opens to this arc right here, and over here on the blue side, this inscribed angle also opens to that same arc. So those two inscribed angles are equal, so that means I can let the algebraic expressions equal to each other. Sorry, this is going to be 3x plus 3. And what I'll do here is I'll interchange the 2x and the plus 3. I will switch positions. So if I do that, I would get 3x over here minus the 2x, and then I would have 15 over here, and then minus the 3. So that's going to be 12 equals to x. Now, that's the value of x. The question is asking us for the value of angle A. All right, so let's go back to the original problem. Where is angle A? Angle A is right there, so what's this value there? Well, it's 2x plus 15. And we know that x equals to 12, so this 12 will just go over here now. So that would be 2 times 12 plus 15. So that's going to be 24 plus 15, which is equal to 39 degrees. So this is going to be 39 degrees there. Okay, let's move on to letter F. Now for letter F, this is a problem that I normally do in class because one of the properties that you need to know for this particular problem, you need to understand how a pentagon behaves. Pentagon is something with 5 sides, 1, 2, 3, 4, 5. And for a pentagon, each side has a value of 108 degrees. So that's one of the kind of properties that you do need to know about a pentagon. And for a pentagon, the interior angles, the inside angles, they add up to 540 degrees. So if you add up all this, that gives you 540 degrees. So each individual angle is going to be 108 degrees. Now, knowing that fact, I'm just going to plug in 108 degrees right here. And I'll go ahead and plug in 108 degrees there. And then you can start to see how the problem is going to unfold because as you can see, these sides indicate that those sides are equal. So you have an isosceles triangle there. So we've dealt with a few isosceles triangles already. So if I do 180 degrees, subtract the 108 degrees, I get 72 degrees. If I divide that by 2, you should get 36 degrees. So what that means is these corner angles are going to be 36 degrees. Now, one of the reasons why that's helpful is because if I look at this entire blue angle right there, that entire blue angle, remember, it adds up to 108 degrees, right? So if I have 108 degrees and I know part of the angles are 36 and 36, then I can find that third missing side, or that third missing angle, by simply subtracting 36 from, by doing 108 minus 36 minus 36, and I end up getting 36 there. So this is also going to be 36 degrees. All right, so that's how you do that particular problem, and that problem's a bit easier to do if you know that the interior angles of a pentagon have a value of 108 degrees. And that's going to be useful for the next problem too, because for the next problem here, I need to find angle number 1, which is right there. Now, angle number 1 is equal to all these other angles because it's marked that way for this particular problem. So, anyways, angle one shouldn't be too hard to figure out because if I look inside the middle here, once again, what shape is that? That's a pentagon, and I know that for a pentagon, all the interior angles add up to 108 degrees. Okay, now we can use this to our advantage because over here, this is angles on a line in blue, right? So angles on a line mean that the two angles add up to 180 degrees. So if one angle is 108 degrees, I can subtract 108 from 180. So 180 minus 108 would be 72 degrees. So if I had to just kind of blow this up a bit more, this is 108 degrees, and this is going to be 72. And over here in green, this is 108 degrees here, and that means this has to be 72 degrees. And now we have our triangle right here. So if I take my blue marker now, do you see that triangle right there? Yep. So since I know the two bottom angles being 72 and 72, I can find out the third angle by doing 180 minus 72 minus 72. And then if I do that correctly, I should get 36. And here is 36 degrees for angle number 1. Okay, so that completes that particular problem. Let's move on to letter H now. Okay, so for letter H, I have an inscribed angle right there. And for all the inscribed angle problems, let's go ahead and follow its sides, and it opens to this arc right here. And what that means is over here, this is another inscribed angle, and if I go ahead and follow its sides, it also opens to this exact same arc. So this is going to be 30 degrees as well. And since that's 30 degrees, here's my triangle here in blue, which we know that angles in triangle add up to 180 degrees. So this third angle has to be 100. And then I have angles on a line right there. It's one of the main properties that has come up a few times. So angle 1 has to be 80 degrees there. Okay, let's move on to the next set of questions in the homework package. question number 3a. Okay, so for 3a, this one's not too bad. Right away, I know I have angles on a line right there. So I can do 180 minus 70 degrees, and that's going to be 110. So this is going to be 110 degrees. And then I can mark in my radius. And then as you can see in this triangle, I have an isosceles triangle there, and that means the two corner angles have to be equal. So both of these angles have to be 35 degrees each. And that should finish off that particular problem. So angle number 1 is going to be 35 degrees. Okay, let's move on to letter B. Okay, so for letter B, I need to find angles 1 and 2. Now angle number 1, this is an inscribed angle because it opens to this arc right here. And you'll notice that just below here, this is also an inscribed angle because it's an angle that opens at the edge of a circle. And if I follow its sides, it also opens to that arc. So if this is 35 degrees, that means angle number 1 also has to be 35 degrees. All right, so it's 35 degrees because inscribed angles that open to the same arc are equal in angle value. All right, now let's take a look at angle number 2. This is a central angle, so I'll say CA. And if I follow the arms on the CA, it also opens to this exact same arc. Now the relationship is that the central angle, since it's closer to the arc, is going to be double the value of the inscribed angle. So if I do 35 times 2, that's going to be 70 degrees there. So angle number 2 has a value of 70 degrees. Okay, let's move on to letter C here, and this is an inscribed angle, and just like the previous problem, this is the central angle, so this is CA, and both the IA and the CA, they both open to this arc right here, so that means the central angle is going to be double the inscribed angle, so this is going to be 80 degrees. Alright, that's helpful because now I have an isosceles triangle here because the radius there are equal, so if you have 180 degrees, I can subtract the 80, which gives me 100 degrees, and that has to be shared equally into the two corner angles. So both of these angles have a value of 50 degrees. And that should be it for that particular problem. Let's move on to letter D now. Okay, so for letter D, one thing that you might recognize here are these two markers right there. So the bigger triangle, this bigger triangle is an isosceles triangle, and we might need to worry about that a little bit later on. But let's take a look at this side triangle right here in blue. Okay, so you might notice that the radius here and the radius there, they're equal. So we do have another isosceles triangle there. So we can use the isosceles triangle property. So that would mean that these two angles have to be 25 degrees apiece. So 25 plus 25 is 50, and 50 plus this 130 gives you the 180. So those are 25 degrees apiece. Okay, let's erase this. Okay. All right, let's look at the bigger triangle now. Actually, no, let's take a look at this angle right here. That's an inscribed angle. And this right here is a central angle. And if I look at the inscribed angle, and if I open up to this arc right here, and if I look at my central angle, it also opens up to that exact same arc. So if the central angle is 130 degrees, that means the inscribed angle is going to be half of that. So half of 130 is going to be 65. So that's going to be 65 right there. Okay, so that's going to be important because now I can take a look at the bigger triangle, and let me just do the bigger triangle again on the side here. I know that it's an isosceles triangle because those sides are equal. Now this is 65, so that means that this has to be 65 as well. Well, we know that angle, this big angle right here, we know we have 25 degrees already, but that entire angle has to add up to 65, so that means this angle here has to be 40 degrees. And if I go back to this bigger triangle here on the side here, I know that triangle has to add up to 180 degrees. So that means that the top angle has to be 50. And since we've taken 25 already, that means angle 1 has to be 25 degrees. And that's how you can do letter D there. Okay, let's move on to letter E now. Now for letter E, this blue line is a radius, so I'm going to mark that in as a radius, and this blue line is a radius, so I'll mark that in, and this blue line right here is also a radius, let me mark that in. So now we have an isosceles triangle, two of them. So if this is 120 degrees, that means this should be 30, and that should also be 30, because 30 plus 30 is 60, and 60 plus 120 is 180. Okay, and if this is 110, 180 minus 110, 70, so this should be 35, and that should be 35 degrees to complete the isosceles triangle. Now, I need to find angle ABC. Angle ABC, so this is ABC, angle ABC is this angle right there, so 30 plus 35 is going to be 65 degrees, so this particular problem has an answer of 65 degrees. Okay, let's move on to letter F here. Okay, let's take a look at letter F here. So I would go ahead and I would try to find this angle right here. Okay, so I do know that this entire part right there adds to 360 degrees. So if I do 360 minus 160 and minus 70 degrees, that should give me the value for the missing angle. So that's going to be 130 degrees. So what did we just find? We just concluded that this angle here has to be 130 degrees. Now this is a central angle, right? So if I follow its sides, it opens to this arc right here. And if I take a look at angle number 1, this is an inscribed angle, and if I follow its sides, it also... Okay, so that didn't quite work. Let me just kind of move this around a little bit. Let's look at this angle, this central angle right here. This is still an angle in the middle of the circle there. So what's that angle there, that entire angle? That's actually 200 degrees, right? So 130 plus 70 is 200 degrees. And if I now follow, let me just adjust my problem, let me just adjust the strategy here. If I follow the sides here, it still opens to this arc right here. And this inscribed angle, that one right there, if I follow the blue sides, it also opens to that arc as well. So the general rule is that the inscribed angle is always going to be half the central angle. So since the central angle has a value of 200, that means this has to be half of that, which is 100. So for letter F, angle 1 is going to be 100 degrees because the inscribed angle is always half the value of the central angle. And the central angle that I'm using this time is this entire angle right here, and that has a value of 200 degrees. Okay, so sorry for that one. I did have to adjust my thinking for that particular problem. Okay, let's do 2 more and then we'll stop this first video. Okay, now for this next problem here, let's go ahead and draw another radius right here. And if I do that, I've created one radius there, and there's another radius there. So now I can start using the isosceles triangle property. So if this is 36 degrees right here, that means this has to be 36 degrees. And then we can solve the rest of this triangle right here because triangles add up to 180 degrees. So 180 minus 36 minus 36. Hold on, let me just do that really quickly here. That's going to be 108 degrees. So this is going to be 108 degrees. Okay, so let me just erase all that now. And I do know that this angle here in green, this 125 and this 108, that whole section has to add up to 360 degrees. So now I can do 360 minus 108 minus 125. So if I go ahead and do that now, this will give me a value of 127 degrees. So this will be 127 degrees right there. And remember, I have an isosceles triangle here. So this blue triangle there, that's also an isosceles triangle. So I can do 180 minus 127. So 180 minus 127, that's going to be 53 degrees, and then I can divide that by 2. And that's going to be 26 and a half. So these two corner angles will be 26 and a half. All right, so that's how you can solve that particular problem. Okay, let's move on to letter H here. The last one for this first video for lesson number 2. And the first thing I'll do is this right here is a central angle, and I need to find angle AFC, which is angle AFC is actually this guy right here. So let's just put a green dot there. That's going to be angle AFC. Okay, let's take a look at my central angle now. My central angle is right there, and if I follow the sides, it opens to this arc right here. And if I take a look at this inscribed angle right here, angle D, if I follow its sides, it also opens up to the same arc. So the relationship between the central angle and the inscribed angle is that the inscribed angle is half the value of the central angle. So if the central angle is 150 degrees, half of that is going to be 75. So that's going to be 75 right there. Okay, I'm going to erase that. And one thing later on here, that's angles on a line. So if I do 180 degrees minus 75, let me do that really quickly here. 180 minus 75, that's going to be 105 degrees. So this right here is going to be 105. And what I can do next now is, here is another inscribed angle. And if I follow the inscribed angle, it also opens to that same blue arc. So this is also going to be 75. And this also has to be 105. Okay, that's pretty good. And now there's this diamond shape here, which kind of looks like a kite. And that's going to add up to 360 degrees. Because if you think about it, if you have a triangle, we know a triangle adds up to 180 degrees. And if I put another triangle underneath it, that's also 180 degrees. So 180 plus 180 is going to be 360 degrees. So this whole thing, this diamond shape right here, which kind of resembles that, the interior angles add up to 360 degrees. So I have 3 of the 4 angles. So I have 105, 105, and 40. I can easily find angle F. So to find angle F, it's going to be 360 minus 105, minus 105, minus 40. And if I do that, I should get, I'll do this really quickly here, should be 110 degrees. Okay, so let me just erase all this now. We know this is going to be 110 degrees. And I know that these two angles, they're vertically opposite angles, so that also has to be 110 degrees. And that is the answer for angle AFC, because that's the angle right here, which is what we're trying to find. Okay, so angle AFC, so that's this angle right there. Okay, so that concludes this video, and I will continue the rest of the homework solutions in part 2.